Hello, I'm Sri Doddapaneni. I welcome you to the Intel Performance Analyzers Virtual Forum, and I'm delighted for the opportunity to speak to you today. I lead Performance Analyzers Engineering at Intel. I would like to share with you some significant new capabilities that are added to vTune and Advisor products in the last year and give you a view into the future direction. Ilias Katsardis from Google Cloud Platform will join me to talk about the HPC in cloud and his thoughts on how we can make that journey easier for you. Next, I'll go over the agenda. I'll briefly go over the agenda today. I'll be giving you an overview of the One API specification and the One API toolkits, and then talk about how analyzers support One API programming model, and then invite Ilias to talk about the HPC at Google Cloud Platform, and then share with you my thoughts on how the cloud technologies pose new challenges to developing in the cloud, and how we are trying to address those roadblocks to make it easy for you to use Intel Performance Analyzers to optimize your cloud-bound workloads. Finally, I'll talk about the technical talks we lined up for you today, and I encourage you to attend them all and provide your feedback. So with that, let me jump to the first segment, which is the One API overview. So first, I want to talk to you about the motivation for One API. So what's the programming challenge today, right, in terms of targeting your workloads for multiple architectures? With the proliferation of the data, growth of the data, and the advancements in terms of compute, storage, and network, it's becoming the new class of workloads that are emerged that are best served with different architectures. For example, the vector, spatial, and matrix architectures. Plus, some of these workloads are so ubiquitous that domain-specific accelerators are quite economical to do, and they provide even further performance than a general purpose processor does. So what that means today is that today you write your code for each of these diverse architectures and use different suites to program those architectures. That means that you are investing for writing specialized code for each of them, and your investment doesn't get scaled or reusable when you wanted to pick a different architecture of choice, right? So there's no freedom in terms of moving from one to the other without paying a significant tax. So with that, I want to show you how One API addresses this challenge. So One API programming model is providing a unified programming model and associated libraries to basically build your application code that's portable to all these different architectures and offer close to the native performance. Next, I want to talk about how HPC workloads are accelerated in Google Cloud in partnership with Google. So here is a case study that we jointly produced. So the C2 compute instance provides great performance for HPC workloads requiring, basically it provides about 40% higher performance per core. I'm going to focus more on Intel tools role here, and then highlight the comment from Ilias. So the Intel MPI, Intel vTune, and Advisor are used on a diverse set of workloads, HPC workloads, and in combination with the Google compute engine provides the best performance. Here is a quote from Ilias. We recommend using Intel MPI for best performance. And retune profiler and advisor to help better understand the performance optimizations. Next, at this point, I want to invite Ilias Katsardis to talk more broadly about the Next, I want to invite Ilias Katsardis from Google on talking about the general momentum of the HPC in Google Cloud Platform, and also his thoughts on the challenge and the opportunities for developer tools to enable the journey to cloud environments. With that, Ilias, welcome.
Hello, Sri. Thank you and the Intel team, of course, for inviting us over. What a great progress you guys have made already, especially compared to last year, right? Many congratulations. Of course, we haven't been sitting idle either. So please let me give you a quick overview of where we are today. The first slide you will see is basically how we are considering the HPC infrastructure in the cloud world. So you will see it's very much like to what you have in a typical on-prem environment, right? Compute, storage, and networking. Of course, the hidden component and the hidden sauce is our partners, one of whom is you. And thank you very much for all these wonderful years, I think more than 10 already, that we are working together. And of course, the really high pace that we have picked up with HPC over the last 3 already, keeping count. So starting from what we have, right? So you can see we have a plethora of different machine types, different CPU clocks. We go all the way back to Sandy Bridge and Ivy Bridge even, right? And then different storage options. I'm not even gonna go deep into those because we need another talk just like this, right? But the point is that cloud gives you a lot of options, right? And these options really make you want to choose the best one, right? Especially if you take into consideration how we have improved the performance on top of this hardware that we actually have, right? So you can see, for example, the one-way latency that we're getting through our network over the last year. This is the improvements that you would expect as a customer from our compute optimized Cascade Lake instances. You can see that we started from 28, which, microseconds, which was the baseline last year. And today with, a gradual improvement, we are at 7.5 microseconds. So the contract or the machines that you have gotten up a year before, it's not the same today. Last year, it will be 32 gigabps. Today, it's 100. So that brings up the need for constantly profiling and monitoring and tuning your software, your code, along the lines of the new infrastructure that we put in place, and they constantly evolve. Of course, we're trying to make easy for our customers to either understand, do they need to increase the performance on the VMs, or do necessarily need to maybe, let's say, decrease the number of cores that they have in an instance, or the hardware specifications for that, and save money in case they're not needing these resources, right? But the issue here is that we are doing a lot of work automatically. It does come, however, after we get some data, right? So we need to wait to understand a little bit their usage patterns. And in an HPC environment where you might spin this code for 24 hours, you run your workload, then you run nothing like it, then you are losing this critical information. And that's where VTune could get in, and does get in, right, into giving you, like, let's say, the adult look of the world, right? So you're not a kid in a sense of, you did something, now you're learning from your mistakes, right? But you can think about it beforehand, you can optimize your workload, you can understand what your software is doing better. And that is especially true because we're offering our customers the custom VM saves, which means that, from the low end to the high end, you can choose anything from one vCPU, let's say, to 80 vCPUs in the N2 VMs. And of course, we have more virtual machines that allow you to do this. And then you can also match it with the memory. So that brings up the question, like, if you were having a compute optimized workload, would you want more compute? Would you want more memory? Do you need the memory? Because whatever you change in these bars basically affects the price that you're going to pay. And let's say the classical example I offer is like, if your code is memory bound, you only get so much memory bandwidth from one node. Keep adding cores to it. If you don't really need them, then why pay for them, right? So you can finely tune the machine over for your software. And on average, we have seen savings up to 19%, for example. And you will see some specifically for HPC. So first thing first, we have run the same code, WRF, from N1 to C2. So out of doing nothing, just by changing machine types, you get a 2.1 improvement, right? Fold improvement. And you didn't really need to do anything, right? You just click a different button, you send this over to the C2 instance, which is the Cascade one, Cascade Lake one. However, we do offer you the option to use these customized VM saves that we mentioned previously, right? So now if you go, for example, we have done this with GROMAX and AMD. We said, okay, C2 could be the default good choice, same choice that you could use. However, if you were able to just get half of the memory, for example, from an N2 node, right? What would then the performance per price ratio would be? And as you can see, just by reducing the performance by a little bit, you actually reduce the memory by quite so much, right? And then the price has a knock-on effect as well. So overall, you might have gotten an N2 custom node, which has 80 vCPUs now, but in a frequency that is lower than the Cascade Lake on the compute optimized VMs, but you need less memory, so the price is affected, it's lower, and overall you're better performance per price wise, right? So that makes you think, really, and that's something we have been discussing, Sri, all over again and again and again over the last year, right? Like, basically you are moving into this paradigm shift, this part of the world where, you're not now buying a cluster, putting it for 4 years into your data center, and then really trying to get the max out of your software and the performance you can get there to finally tune it to that piece of machinery that you have, basically. But you are living in a more adaptable world where it's basically, you can change to any of these types with the click of a button, really, and you can get more performance out of the box. I have been in my career before, I have been seeing basically the same codes, like millions of lines of code that they had like maybe 2 or 3 or 5 or whatever, different pieces of code that, if you are in a compute bound situation, then you recompute. If you have a very fast memory bandwidth, then it's better to save it and bring it back, right? So in this case, you don't need that, right? You can do whatever you want that is wisely for your software, and then finally tune the software to the exact hardware that makes it shine, right? And that's basically my presentation. Please feel free to join us on Cloud, Google, HPC. And thank you very much.
Thank you, Ilias. That's exciting to see the advancements in terms of the Google Cloud Platform support for HPC and the successes you had. Congratulations. So now I want to focus on coming back to the cloud environment and how we support analyzers in cloud environment. So traditionally, we have been Intel performance analyzers are arguably the best in the industry in basically giving you the full visibility across the software hardware stack, right? So providing full visibility all the way into the hardware layers at the very bottom. However, to continue to deliver that similar kind of developer experience in cloud environments, Then a number of new challenges come up, and I will talk about primarily what is driving those challenges, right? So one is the infrastructure as a service, and then the microservices and other serverless architectures for application modernization and management of the application lifecycle. These all kind of put new barriers, and I'll talk more about them in the next slide. So infrastructure as a service is basically underpinning that is virtualization technologies. So physical servers or systems are de are partitioned into a modular compute engines, and that to basically match the demands of the applications, as well as to really improve the utilization of the resources. And virtualization, of course, started before the cloud, but it is an essential technology that drives the infrastructure as a service. And then in that, some of the other challenges also is software-defined way of configuring your cluster and your system and network. Um, and then having orchestration tools to launch your workloads and manage their life cycle. So virtualization in itself limits the ability to have access to hardware-based monitoring, at least as rich as we are able to do it on bare metal systems, right? So that's a huge challenge because of the multi-tenancy, and hypervisor usually will prevent you from gaining access into the system-wide telemetry for each of the guests. But that said, there is a narrower definition of hardware-based monitoring that's especially focusing on the core-based monitoring that is still compatible with sandboxing that multi-tenancy requires, and especially this is enabled already in AWS and with in cooperation with some of the hypervisor vendors, and we are working with other vendors to make that possible. So that's one area. The next area that what challenge is, as the workload is uh, um, running on this virtual environment, in general, you don't pin on which particular system your application is going to run. So the traditional way of interactively launching your application using vTune doesn't is not usually uh, possible. And what we needed to do was essentially defrag the vTune into data collection commands for data collection, commands for analysis, and then have the UI essentially be embedded in a browser and easy to access from the cloud. And I will show you later how we are able to achieve that in the current release of vTune. Next, I'm going to talk about the serverless and microservices. So basically, the containers and orchestration or new technologies that further pose challenges. So in terms of the microservices architecture, a monolithic application is decomposed into components, and each component is containerized and offered as a microservice. However, the Kubernetes is used basically to orchestrate and manage the life cycle of these microservices. So the beauty of this architecture is, of course, that you are able to more modularly deliver updates to your application. You don't need to update the entire application, only the component that needs update, as well as be able to scale your components. So in this model, the 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 the, the the microservices are scaling on demand, and we needed to be really able to put vTune and other data collection as part of your microservices configuration. And in additionally, we may also need to offer analyzer in a container form so that it is easy to bring up the new instances of the analyzer server to support the web UI invoked by the users. Finally, I'll touch on the one of the value props that Ilias was talking about, where there is a paradigm shift. So instead of thinking that you are optimizing your software for a fixed hardware configuration, you have at your disposal a wide variety of hardware, basically different compute engines that cloud offers. Um, that you are not, you are free to basically exploit them and then on demand require whatever you need. And what that means that you could think also is that there is another important optimization flow where you have a reasonably performing code base, and now you're trying to figure out what is the optimal compute engine and storage and network that meet your application needs and maybe give you the best performance or maybe the lowest cost, right? Whatever it may be. So we need to think about how to enable that kind of tuning and workflow. Next, I'm going to talk about the vTune profiler server usage model. So here, the vTune server is running in the cloud or in your data center, and a team is able to essentially use that server for all their analysis needs. So any workload that's running on any of the target systems in your network can run the vTune profiler agent, and then the agent will basically call back into the server for authentication purposes and for security. We are following basically the agent is the one that handshakes with the server, and once it handshakes with the server, you are able to do the normal remote system profiling that you're able to do from your web UI and be able to analyze the results in your web UI. And this kind of eases some of the developer experience that when using in the cloud, though there are more challenges. And so this is, I would consider this is a significant progress, but we are not stopping there. So, and I'll also talk about what more we needed to do. So we have a number of technical talks put together that I wanted to briefly give you an overview and encourage you to attend those sessions. So Ilias Katsardis is going to talk about the top-down topology-aware I/O performance analysis. This is a unique new analysis capability. I don't think you'll find it anywhere else. It's based on the hardware monitoring of the I/O paths in the Xeon platform and provide you a insightful view into how your I/O bound application is performing at the lowest level and what bottlenecks are limiting your overall application I/O performance. Next, Murad Rochev is going to talk about intelligent performance engineering. So he will show about how he's using OpenVINO and vTune in his intelligent performance engineering experiments he has run, and it's a very interesting talk. I encourage you to attend it. And Corey Levels is going to show you how you can take your high performance workload and understand based on the CPU profile, what portions of it are profitable to offload to your to a GPU, and then also talk about whether the kernel is optimally performing using GPU roofline. Um, Kevin O'Leary is going to talk about debugging uh, your parallel code for threading and memory errors using Intel Inspector. Finally, Jennifer Dimitio and Corey Levels will do a walkthrough, illustrated walkthrough of using Advisor and vTune to design and tune your application for GPU. With that, I want to conclude. One API programming model is an open specification and that is getting traction with multiple vendors, and Intel provides a robust reference implementation and delivers them as one API toolkit. I encourage you to download and look them up. Intel performance analyzers are part of the One API toolkits, and as well as they're available as standalone. And they provide industry-leading capabilities both for One API programming model and for your traditional compute on the servers and client CPUs. And we are continuing to further enrich the support for One API. Finally, I want to show you that we made some significant progress in easing the developer experience when using the tools in cloud environments. And also, uh, we are exploring further improvements and are interested in learning about your needs and your thoughts on how we can improve the usage of the analyzers as you move to adopting cloud environments for your software development. So with that, I want to thank you and thank Ilias for joining me today and sharing the wonderful advancements at the Google Cloud Platform.